Hi, welcome to the Neuro Revision Lab. In this video, we're going to take a look at one of the two possible rates of reaction required practicals. This is required practical 11. This one focuses on measuring rate by volume of gas, which you may recognize from the equipment, either a gas syringe or an upside down measuring cylinder. The things that you'll need to know about first are collision theory and rates of reaction, which we've covered in our previous videos. By the end of this video, you should be able to recall the method for investigating the effects of concentration on the rate of reaction. You should be able to plot a graph of the results and explain the results in an extended answer. The keywords this time are concentration, rate of reaction, volume of gas, collision frequency, gradient, gas syringe, and measuring cylinder. Take some time to write these words down in your revision books. Practice spelling them, sounding them out, and listen carefully to how they're used so that you can research their definitions later. Required practical 11 for rates of reaction can be carried out using either of these two methods. This particular setup is very flexible. It can be used to investigate changes in surface area or concentration. You can even use different reactants. Here, we're going to assume the reaction is magnesium and hydrochloric acid, which produces hydrogen gas. However, many teachers choose to use calcium carbonate and hydrochloric acid instead, which produces carbon dioxide. This is often considered safer as hydrogen gas tends to be a bit explodey. The first experiment uses a gas syringe. The reactants in the conical flask produce gas, which pushes the syringe outwards. The graduations on the syringe allow you to easily measure the volume of gas produced over time. The second version is slightly more complicated. If you've ever set one up, you'll know it's much more awkward. Instead of a gas syringe, a delivery tube bubbles the gas under an upturned measuring cylinder filled with water. The gas displaces the water, and by reading the upside down scale, you can get the volume. This is usually where you have to trust your lab partner not to knock anything over. Sticking with the gas syringe version, because everything after this point works pretty much the same, your independent variable, the thing you change, is the concentration of hydrochloric acid. Your dependent variable, the thing that you measure, is the volume of gas produced over time. Your control variables will include the mass of magnesium or calcium carbonate, the surface area of the reactant, the temperature, and the volume of acid used. These are very common single mark GCSEs, and they're often thrown in there just ahead of much longer questions. So here's your trimmed down method, kept simple to make it accessible and efficient. Describing methods is a very common 6-marker, and this one has appeared several times in recent years. Number 1. Measure a fixed volume of hydrochloric acid. Number 2. Pour it into the conical flask. Number 3. Make sure that the gas syringe is empty and ready to collect gas. 4. Add 1 fixed length of magnesium. 5. Quickly seal the bung and start the stopwatch. This is a very common source of error. 6. Record the volume of gas every 10 seconds. 7. Continue until the gas volume stops increasing. And lastly, repeat with a different concentration of acid. Here we have a typical results table. This version of the practical is all about drawing the graph. So pause the video, grab some graph paper, and have a go. I've included my version of what your graph should look like. To analyse your graph, you would say that 1.5 mole per decimeters cubed has produced more gas per volume over 60 seconds. Then 1 mole per decimeters cubed has produced less gas per volume over 60 seconds. Both initially react quicker and then slow down. In conclusion, increasing the concentration increases the rate of reaction, which we already knew that, but now we can say that we've proved it. At this point, this is what your revision should look like. I know it seems like a lot, and it is, but required practicals are hugely important and make up a large part of your upcoming exams, so it's important to give it enough focus. Pause the video here and make any improvements before moving on to the exam question. Okay, so your exam question. These are typically questions that are added on to the end of required practical analysis, and they usually are extended questions. As always, let's highlight the command words first so we know exactly what we're going to be asked to do, and then highlight the keywords. Question A. A student investigated the effect of changing the concentration of hydrochloric acid on the rate of reaction with magnesium. Describe a method the student could use to produce valid results. Question B. Explain the effect of increasing the concentration on the rate of reaction. Refer to particles and collisions in your answer. Pause the video here and have a bit of a go. The answers will follow shortly. For more revision resources, tips, and helpful materials, please visit the Neuro Revision Lab store. Everything there is specifically selected or created for neurodivergent learners, and every purchase supports the channel and helps keep us producing video content. As usual, subscribe, like, and share. Alright, let's check those answers. Question A. A student investigated the effect of changing the concentration of hydrochloric acid on the rate of reaction with magnesium. Describe a method the student could use to produce valid results. It's a 6 marker, so we need 6 bullet points. And this refers back to our method from earlier. Measure 50 centimeters cubed of 1 mole per decimeters cubed hydrochloric acid into a conical flask. Add in a 3 centimeter strip of magnesium. Start a timer, collect the gas in a gas syringe or an upturned water-filled measuring cylinder, record the volume every 10 seconds, and then repeat with a different concentration, for example 1.5 mole per decimeters cubed. Anything along those lines and you'll get all 6 of those marks. It's very important that it's possible to get valid results from your method. That way you can ensure that you'll get full marks. Question B. Explain the effect of increasing concentration on the rate of reaction. Refer to particles and collisions in your answer. Also 6 marks. This refers back to your collision theory and relating it to this practical specifically. Increasing concentration means there are more particles in the same space. This makes the particles much more crowded together. The particles collide more often, meaning a higher collision frequency, with more successful collisions in a set time. Therefore, the rate of reaction gets faster. If this video helped you, you'll love our specialist neurodivergent notebooks designed to make learning clearer and easier. Grab yours from the link below. Otherwise, check out our other videos, review some prior knowledge, or move on to a new revision topic. Subscribe, like, and share, and I'll see you next time on the Neuro Revision Lab.